Hey everyone, welcome to episode 14 on our Linux series. In this episode, we are going to learn about Linux processes and we will try to cover more on coming episodes as well. However, in our previous episodes, we have briefly covered some of the interesting concepts of Linux. If you have not watched it already, please watch it. There will be a link in the description and in the pin comment to the playlist and to the latest episodes. If you have not watched it, please watch it. So in this episode, we are going to cover what exactly is a process, what are the different types of processes, how the process scheduling and the states work in Linux, what is the difference between a process and threads, followed by some of the commands in the CLI used in processes. So without any delay, let's jump into the topic. So what exactly is a process? So process you can consider as an instance of one or more related tasks executed on your computer. For example, let's say you have started an application, you have launched a game, or you have run a program, or you have opened any application on your system. Eventually, it creates a single process or multiple sub processes in the form of thread within your system. And the main work of the process is to utilize the CPU to execute your program or execute your application to make your program running efficiently on your system, right? So when it comes to processes, as I mentioned, a single program or a application itself can create multiple or several processes simultaneously to make the program running efficiently, right? And there will be a lot of processes which will be running in your system, out of which some processes will be completely independent or independent from each other, or there may be several processes or sub processes combined with each other or tightly coupled to make your application or program work efficiently. So in that case, failure of a single process may or may not affect the overall running of the system. Some processes can still fail, but your application still run. But it can also break your overall application to function as well. So that is why process is very significant. To understand it or understand its functionality is very pivotal if you are working with Linux, right? So process or the overall functioning of your program, you can consider it is in a three layer. First layer is your execution of your program, which eventually creates a process or multiple processes. Then again, process cannot work or can or cannot work independently. It has to delegate its tasks to utilize or take the resources for executing in properly within your system, which then again segregates into multiple threads, or it divides its works to multiple worker or threads so that it gets executed parallelly on your CPU or in your computer to make the program running. So that is how a overall program gets its job done from its process, and process eventually divides it into thread. That is how it works. So you can consider thread is a subset of a process and process is a subset of a program. As simple as that, right? Now, moving on, what are the different types of process which is available? Most of the time, people try to understand your fundamental knowledge about your process by asking what other types of process you know it. Most of the time, people fail to answer because the fundamentals is most of the time is being missed. Whenever somebody asks is a process, everybody understands as is just a background process or just simple process which gets executed by a program or application. But in behind, multiple segregations happens, and we need to understand it thoroughly. That is why understanding the process type is very important. So what are the process types? First is your interactive process. Whenever a user or logged in user starts a process via your command line or clicking an app, the process which gets executed or started is known as your interactive process, right? And it can be a bash, it can be Firefox, stop, any command which you are running, that are all part of the interactive process. That is the first type of process. Second type of process is your batch process. When you want to automatically execute the process or automatically execute the program to run in the background without hampering the user or overall functionality, you try to run the program in the batch mode or in the background mode. What is a background process? What is a foreground process? We'll try to understand in the next episode, but those are all part of your batch process. What are the different types of batch process? These are few of the batch process example: update DB, ID config, etc., etc. These are part of the batch process, right? Third is your daemon process. So daemon process is nothing but a background process that runs continuously via a server. For example, let's say you are installing an Apache server within your Linux system. That particular process will be known as your daemon process, which again gets converted into multiple processes, and eventually it creates a server or cluster of process, which known as a daemon process. What are these? HTTPD, SSHD, CUPSD, Nginx, all are daemon processes, which eventually triggers multiple processes altogether. Then the fundamental units or small processes will known as a thread. As I mentioned, multiple threads creates a single process, and process delegates its works to thread so that it can work parallelly to get the resource to get the job done. So right, that's what it mentions. Small part of the process that shares the resource with each other. What are these examples? These are some of the examples of the thread, how it looks, how to define or segregate between or understanding which is a process, which is a thread. We will see it in the example. Finally, the kernel thread, these are nothing but your system managed thread run by your kernel. Whenever kernel runs, it initiates multiple processes within your system. That again gets segregated into threads. Those are known as your kernel thread. And this is different from your normal thread, which is user managed or root managed. Kernel threads are something which is controlled by your kernel, and a normal user doesn't have any authority to control it. And hampering or playing with it is also not recommended, or else your kernel may crash or system may not function. Right? What are these? These are some of the examples of your kernel threads, and it gets also a part of the process. So these are few of the process types. You should understand it and try to understand the segregation between all that, so that whenever somebody is trying to ask, you can elaborate it properly. Hope you get it. How exactly process works in your kernel, right? So there are two important things which you have to understand in this context. So you can consider that kernel, there is an important kernel function called as your scheduler, which constantly shift the process on and off from the CPU. What does it mean is that whenever you are trying to run a program or you are trying to start a service, it creates a process, right? So if, for example, you might be thinking that kernel is a multitasking or multi-user system, what happen if I start 5 services or 5 processes all together within multiple command line, how your system will behave, right? Because it is a multi-user system, right? It doesn't happen like that, right? So Linux, what it does is it tries to make it as a batch process, or tries to schedule it within a symphony, you can call, to make that process go into your resource allocation or allocate your resource to that process, so that your process can get enough resources to get executed, right? So the main job of the scheduler is to take that processes or read the processes or read the requirement of that process, and based on that try to allocate the resources from your CPU accordingly, right? So your CPU can be a single CPU or single core machine, quad core, dual core, 8 core, 16 core, multiple cores are happening, right? So the core utilization, how to allocate it to a particular process or application, that job is being done by your scheduler. And it's a kernel function which handles behind the scenes, but that is how it works. Try to understand that, right? Now, when it comes to scheduling a process or running your process can go with multiple state, right? Either some process can run, or either some process can crash, or either some process can do blah 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 blah, right? So in that case, Linux actually has 3 different states when it comes to the process, right? What are these? One is your running state, one is your sleep state, and third is your zombie state. What exactly is a running state? So when you are trying to start a process, when a process is going to start or running condition, it is running already, that particular state is the running state. That is one type. Second type, it can be when a process or multiple process is trying to get the resource from the CPU, from the scheduler. That time it can hold off or wait for some time to that particular resource gets allocated to that process. That time also the process will be known as your running state, right? So that is how process goes into running state. Now, when it comes to the sleep state, you can consider, for example, let's say you have executed a program, but that program is looking for some input from the user, right? That is one condition. Maybe that process will be looking for some of the storage to write, or maybe some other process to start before that, right? In that time, that process will go to the sleep state. As simple as that, right? It will not taking any resources, or it will not be utilizing any system or memory, but it will just hold up without any doing anything. It will just looking for an input or any dependent thing. So that time process goes to your sleep state, right? As simple as that. Finally, the zombie state is very important. So sometimes what happens, you have initiated a process and you want to stop it. For stopping the process, it's a slightly different scenario, slightly different method which we follow to stop it, or we call it as killing it. So sometimes what happens when you are trying to stop a service, it may be having multiple processes which is running in the background. When you are cleaning or killing that process, in that time, the main process will be killed, but the sub processes will not be killed. For example, let's say a process has initiated 5 different sub processes and you have killed the master processes. but other fours are still running, or it might be like, in the hold state, or it might be in the crash test. Maybe multiple things happen in the system. That time, those processes will be in your zombie state. And it is a very like, clashy situation when you like, consider in the system class. It's a very bad state of a process to be, and you have to kill the process properly so that it doesn't go to a zombie state. If it is going, then there may be multiple issues can arise. What are those things, how it behaves in production? Please let me know if you want to know more about it. I will be happy to make further videos around it. Okay, I want to see what are the current processes running in my system. The command which I use is ps, as simple as that. Enter. It will show me the information about the processes which are running. Always remember, PS will give you the processes which are being run by the current logged in user, which is nothing but your Ubuntu, right? Now, I want to see all the processes which is running in the system, irrespective of any user boundary. I want to see all the processes. The command which I use is ps-e. So what it will do, it will show all the processes which are running at the moment in the system, right? Whether it is root user, Ubuntu user, or any XYZ user, it will show all the process. The command is ps-e. Now I want to see, here I can see I have 3 or 4 columns for information about the process. What it is, I will explain you in some time. Now, I want to see more information about the process. What it is, I will use ps-ef. So when you run ps-ef, Linux will show you not only the processes, but also many information about that particular processes, right? What exactly it is, let's try to understand each and everything. First thing it will show you is the UID. Who is the user who is running this particular process, right? Secondly, the PID. PID is nothing but the ID which is given by your Linux to that particular process. We understood Linux works as a first in, first out based scheduling. So whoever gets started, it gets a process ID 1. Who comes second, it will get 2. Eventually, it will work in the ascending order, right? So that is how Linux tries to identify the process with the form of PID. That is what the significance of the PID, and it plays a very important role for the administrations. It will come in sometime, right? That is about the PID. Next thing is your PPID, or we call it as parent process ID. Sometimes what happens, as I mentioned, when a process or a service tries to create multiple sub processes, then it can create multiple processes with multiple process ID, but it will come from a parent process. That time you will get a parent process ID, right? So that is about the parent process ID. Next thing is your S time. This is nothing but your the when the process was created. This is nothing but your today's date. Next, the TTY. This is nothing but whether it is a terminal process or it's a background process or any other type. It will tell you about that. Next is your time. As simple as that. What time it was created. Linux timestamp. Finally, the CMD will be what exactly the command or the code which has run for executing that process. So that is how the information you get about the processes, right? How we do? We use ps-ef to know the overall about it, right? Now, I want to know the thread or TID about, or what are the threads which are running for a particular process. There is a process which is known as your SSHD. Let me see how to search for that. I will do ps-ef. I will use pipe followed by grep, and I will search for that process, which is SSHD. Okay. So how to use grep, how to use pipe, how to use this advanced command. If you don't know, please watch our previous videos. There will be a link as well in the comment to refresh your memory. Please feel free to watch it. Now, if I do, here I can see I have got some more information. Okay. So if I want to know the thread about a particular process, the command which I use is ps-elf followed by pipe, grep, and SSHD. And I'll hit enter. So now here it will have more elaborative information. Don't get overwhelmed by the output of the command. You will get it, but try to see the video multiple times to get the overall idea about what are the bits and pieces about the output. It is very important to know that. Okay, many times many interviewers try to ask or try to test your knowledge if you know the fundamentals clearly or not, and they try to open the ps-ef command and try to ask you about getting the each bits and pieces about the comment. Okay, so you have to understand it properly. Now it will show me the user followed by the PID, process ID, followed by the PPID. Next thing which comes is the thread ID. Okay, so this is the thread ID which has come, right? Or we call it as LWP. Now, next thing which has come is your NLWT, number of threads which is running, right? So it is running one thread, you can consider, right? Then again, start time and command or process which has executed it. So this is how we see the thread ID in your Linux, right? Now I want to kill a process or we want to stop a process, how to do it. Okay. Now, what I will do is I will start a process in the background with a sleep command and try to see it. What I will do, ps-ef followed by grep, and I will see the sleep, which is running. Now I want to stop this process. How I will do? The command which I use is kill followed by the process ID. Okay, this is one way of killing it. Okay, but it is not the safe way of killing it. To kill the process safely, it is very important because some process can terminate your system to crash. So you have to clean it properly. You can use kill command, but that is not recommended, right? The recommended way is sudo kill followed by 9, or we call it a safe kill followed by the PID. This is the safest way of killing it. Always remember. Okay. Now we have other commands as well, like we can use pkill followed by the PID. It can kill as well. But killing it safely, we always use kill-9 followed by the PID. Okay. If you want to know how to handle a process in the production, please let me know in the comment box. I will try to make more elaborative video or more fundamentals on working with productions. If you are interested, I will happy to make that. Right. So with that, that's it for today. Hope you like it and you got the concept very well. If you have not, please put your thoughts in the comment. I will try to answer all your queries. Please join our Discord community for having more one-in-one elaborative sessions on your doubt clearance. With that, thanks for watching. See you next video. Bye bye.